Okay, 1.8 combinations of functions. We're going to add, subtract, multiply, divide, and do composite functions. So again, like I'll said over and over, it's kind of a review. So two functions can be combined by operations of addition, subtraction, multiplication, division, just as two real numbers can. For example, find the sum of f and g using the graph. So how that would work is x's are inputs, y's are outputs, correct? Yes? Okay, it only works where they overlap. So this is f on the top, g on the bottom. -2, will this work? Can I add negative at -2? So it only works where they overlap. Can I use x is -2? Why not?
They don't overlap.
They don't overlap. Okay, can I use x is -1?
Yes.
Yes, because on f, when x is -1, y is 0. And on g, when x is -1, y is what?
Negative G?
-1.
Negative 1.
Okay, so 0 plus -1 is what?
Negative 1.
-1. So the point would be at, can you see that?
Yeah.
Okay, so then we can go at 0. So at 0, f is 1.5, so 3/2. G is -2. Okay, so what's -2 plus 3/2?
1/2.
1/2. So the answer would be at 1/2. At 1, f is 3 and g is 1. So what's 1 plus 3? 4. So it would be, we'll say that's going to be 4. So our new line would look like this. Why can't I use -2?
They don't overlap.
They don't overlap. -2 and +2, the function, only one of the functions exists at that place. Now, could I do 1.5? Yeah. You could add every single point in there, but should it fall along those lines that I put? Yes. So I could add, subtract, multiply, and divide, and what I added, subtracted, multiply, and divided were the y's, correct? The x's are the x's, the y's are what you would do that to. The domain of an arithmetic combination f and g consists of all real numbers that are in common in the domain. Again, if they're not in common, can you use them? No. Ready? Okay, this is just function notation. I can write it as f plus g of x, or I can write it f of x plus g of x. I could ask you the same question either way. I can say f minus g of x, or I can say f of x minus g of x. I can do fg of x, or f of x times g of x. The left and the right are the same thing. Make sense? Anybody not understand what's going on? On the last one, why does it say g of x cannot be equal to 0? Because you can't divide by 0. I typically do the right-hand way, but then once in a while I'll start doing the left. We just have to know it means the same thing. Okay, find the sum, the difference, and the product, sum, difference, product, and quotient of these two functions. Okay, so f of x plus g of x. So what do I do to them? It says f plus g. Just add them. I'd have 2x minus 3 plus x squared minus 1. And then I would combine like terms. So x squared plus 2x minus 4. So f of x minus g of x. What do I have to remember to do here? distribute the negative. So it would make it negative x squared, and it would make it positive 1. So I have negative x squared plus 2x minus 2. Now on here, I usually go FG of x just because I don't know why. So that means multiply, yes, product. So what do I have to do when I multiply 2x minus 3 times x squared minus 1? I have to distribute. I have to FOIL, don't I? So I'm going to have what? 2x cubed minus 3x squared minus 2x plus 3. And I would combine like terms if there were any like terms, but do I have any like terms? And then f of x divided by g of x. So 2x minus 3 over x squared minus 1. And if I can factor, I should factor to see if I can reduce. Can I factor the numerator? Nope. So it's just 2x minus 3. Why am I putting parentheses around it? Yep, so I don't go reducing stuff that I can't, right? How about the denominator? Can I factor it? X minus 1, x plus 1. So that's divided. If there was anything to reduce, reduce. What can't x equal?
0.
What can't, the denominator can't equal 0, so what can't x equal? Plus or minus 1? So if it asks you the domain, then you'd have to do all of it. It may say state the excluded values. I don't know if it does or not. And again, we all know that we can't divide by 0. Are we good? I like this stuff. I think it's kind of fun. Okay, find the following. So what's the first thing tell us to do? Divide? So do it. Did you get 1 over x plus 2? Okay. Because that was f divided by g. What's b asked me to do? Oh, what can't x be on the first one?
-2.
What about positive 4? Can it be positive 4?
Why?
No, right here.
You look at before the reduce.
Yep.
Oh, we have to do it before.
Yep, we have to do it before. Okay, so what's the next one's b asking? Oh, I forgot my cannot equal. Sorry, Noah. What about the next one?
Same thing. No, you flip it.
You have to, it's the reciprocal, isn't it?
Oh, I didn't.
So my answer here, I'm going to have x minus 4, x plus 2 over x minus 4. So x plus 2 is my solution, and what can't x be?
Positive 4.
Positive 4. It can be 2, this negative 2, can't it? So what's the last thing asking me to do? Plug in negative 1 for x. Now, could I plug negative 1 in before I divide? Yes.
Yeah.
Or I could plug it in after. Either one. So if I plug it in after, I get 1 over negative 1 plus 2. So I'm pretty sure I get 1.
Yep.
Okay. If I plug it in before, I get negative 1 minus 4 over 1 plus 2 minus 8.
Wait, so you plug that negative 1 in for x?
Yep.
Okay.
So then I would get negative 5 over negative 5, which would still be
1.
1. So I can plug it in separately, or I can reduce it and plug it in. It depends. If I have a bunch of numbers to plug in, I would reduce first. If I only have one, I'd probably plug them in individually. Questions?
Is that all we're doing today?
We got combinations. Another way of combining two functions is composition of one and the other. So if I have f of x equals x squared, and g of x equals x plus 1, the composition of f with g, we can write it f of g of x, or we can write it g composed of f with that open circle. Remember doing this last year?
Yeah.
Kind of.
Okay? And we read it as f composed of g. So that means I'm putting g into what?
All of the x's for x.
All the x's in for f. So g or f composed of g of x. So this has to go in for that x. So it's going to be parentheses x plus 1 squared. And then I have to do what? FOIL it, right? Because that's x plus 1 times x plus 1. So that would give me x squared plus 2x plus 2. Oh, how about 1? 1 times 1 is 1.
Yep.
Some days. What about g composed of f?
It'd be x squared.
So x squared goes in for x.
X squared plus what?
So it'd just be x squared plus 1. So is it commutative?
Sure.
What's 2 times 3?
6.
What's 3 times 2?
6.
6. That's commutative.
No.
Is f of g and g of f the same?
No.
No. So is composition of functions commutative?
No.
No. So I'll know whether you do it right or wrong, because you won't get the same answer. The only time you do is if they're inverses of each other, and then we're going to do that tomorrow. This might be the last slide. So what's the first one say to do?
F times g of x.
Not times.
Compose.
How do I know it's composed and not times?
Because it has the open.
Open. So do these.
Should the 4 minus x squared be in parentheses?
When you're plugging it in, yeah.
Mhm.
Well, it doesn't have to be, but it can be, because it's not being squared or anything like that. How'd it go, Dylan? How'd it go? Good. Lily, how's it going? She's ignoring me. She's ignoring me. Noah, how'd it go? Carson? We're at.
I just not doing my math right someplace.
Yeah, I did it wrong on B, but I figured it out. I distributed the negative before.
Okay, why can't you distribute the negative before?
I don't know. I just know I shouldn't.
Order of operations
Oh,
tells
you
me
should do
x.
stuff that's in parentheses first.
Yep, you have to do your exponent first, then your multiplication. Lily, how'd it go? Thanks. That thumbs up was awesome. Okay, do parentheses matter when you're plugging it in? Yes, because if you didn't put your parentheses when you plugged it in, you would have told me I'm wrong. I'm wrong.
Wait,
I'm
so
wrong.
my
I'm wrong.
operation on the negative
I'm
outside of
wrong.
the -2
I'm wrong.
squared in parentheses. Wouldn't that mean it'd be a -4?
Mm-hmm.
No, you just fixed
That's why I said I'm wrong. That's why I said parentheses do matter. And I'm like, wait a second, I'm wrong.
I was wondering.
Because it was -2 times -2 was +4, but then it's times a negative, yes?
Mhm.
Carson, is that where your math was wrong?
Yeah.
So you were right, I was wrong. Questions?
No.
Typical? Is that what you said? Typical?
That's what Carson said.
No.
Do we need it again?
No. We
What's
just
this
have
one?
to-
Wait, what's this one mean?
Where?
F composed of F.
You put
Plus
the
F
F
in
in
for F.
for you put F in for F.
Okay, so do this one
Then you put
and
a -4 in.
so do it.
2 times 2 plus 1.
Just see?
2 times
Yes.
Well,
Wait.
My hand was touching it down at the bottom.
Oh,
It
you
went
waited
right.
till after to put in. Oh, we got the same answer. Okay.
Okay.
You just waited till after to put in the
Mhm.
X, so I was confused.
Yeah, again, you can put it in before, but if I had a bunch of things to put in, I wouldn't put it in before. I'd do it one time and then plug them in, right? Everyone get -13?
Yeah.
Okay.
Wait, I thought I got my
I thought I did it wrong.
No, when I was trying to put my negative, my hand was touching, and so it kept picking up my hand and not the pencil. I think that was last slide. Yep, that's it.